chapter 3, as I said, and we're going to talk about exponential functions. And so first of all, we're going to define what is known as a transcendental function. A transcendental function is a function that cannot be expressed in terms of algebraic operations, such as an exponential or logarithmic function. The root word in transcendental is transcend. What does transcend mean? Because basically where the name came from the word transcend, because what this does is this transcends algebra. Okay, it surpasses algebra. Okay, you cannot express an exponential or logarithmic function in terms of an algebraic operation. You just can't do it. And so that's why they call them the transcendental functions. And so that's what we're going to be looking at this chapter, exponential and logarithmic functions. So today we're going to just look strictly at exponential functions. Should be something fairly easy. The nice thing about this chapter is that you're going to learn about some real world things. Like today we're going to talk about interest, okay, which is something we've already talked about quite a bit in the past. But we're going to look at solving interest problems. And so first of all, I'm going to define what an exponential function with base b is. An exponential function with base b, y equals ab to the x power. We call b here the base. What do you call x?
Exponent.
The exponent. Okay. So we have a times b to the x power. That is an exponential function with base b. A few things about a, b, and x. A can't be 0. Because what happens if a is 0? The whole thing's 0, so you have no exponential function. B has to be bigger than 0. So in other words, B has to be
Greater than 0.
What is B if it's greater than 0?
One.
Positive. There we go. So B has to be positive. Okay, B can't equal 1 because 1 to any power is always 1. So once again, you still have no exponential function. And x is an element of, does anybody remember what that symbol is? Real numbers, right. So x can be any real number. So yes, x could be a fraction. It could be a decimal. Okay, but those are the characteristics of an exponential function with base b. So with that in mind, we talked about those characteristics. I want you to tell me, is that an exponential function? Yes or no? Okay, it is an exponential function. In this case, a is 1. Okay, so it's like in here I have 1 times 4 to the x. B is 4, that is my base. And x is a power there. So let's look at this one. Is 7 to the negative x an exponential function? Yes or no? What do you think? Yes, the reason it is an exponential function is because remember, your power here can be negative. It can be any real number. So it can be negative. Okay, let's try this one. Is that an exponential function? 1 to the x power. One to the x power, is that an exponential function? No. Good. Why is it not? B can't be 1. Right? B can't be 1. Your power, your base can't be 1. Oops, skipped 1. And then let's look at this one. 1/3 to the x power. Is that an exponential function?
Oh, that's cool. It was like alternate.
Yes, it is an exponential function because, remember, b can be a fraction. It just has to be positive. All right, so let's go ahead and look at some characteristics. I want you to take your graphing calculator right now, and I want you to go to, now first of all, what we need to go is we need to go to our apps menu, and we need to turn off our inequals feature, okay, because you probably have the inequals going, okay. So, I need you to go ahead and go to your apps, scroll down to inequals, hit enter, and I need you to turn that off.
Yeah. It's not supposed to
Okay.
be
No. So now I want you to go to the y equals menu, and I want you to type in y equals 2 to the x power. So how we enter that in is we use 2 and a caret x. So you should have 2 caret x, or you should end up having 2 to the x power like this. So go ahead and type that in y1. Go ahead and go to zoom. I want you to go to the Z standard window, and then I want you to look at the graph. You're still in the inequality. That's what I said. Perhaps you have to go down and get rid of that. 'Cause,
Well,
Well,
just
looky
like
there.
It does.
okay, so let's go ahead and look at, see, we're going to turn off the So then now you're going to notice this is an exponential growth function. Why do we call it exponential growth? Because it goes up. Okay. 2 to the x. A few things about this graph. The domain is negative infinity to positive infinity. It's all reals. The range, on the other hand, is not all reals. The range in this case is only from 0 to infinity. What does that parentheses mean? Around a 0. It doesn't include 0. So basically what ends up happening is we have an invisible boundary here that the graph never touches. What do we call that invisible boundary? An asymptote. Good. So then now, the y-intercept in this case is 1. What is the y-intercept in your graph? 1. Okay, I want somebody in this table to graph 3 to the x, 4 to the x, and 5 to the x. I want one to graph 3 to the x and 4 to the x, and one of you to graph 3 to the x.
I'll do it.
Okay, so I don't care, just go back into y equals, and those of you that I said, I don't care, I need somebody else to change it. Okay, what I want you to do now in your groups is I want you to compare the y-intercepts.
It gets steeper quicker. Yeah, the quickly goes to.
It doesn't.
Okay, what did you notice? Those of you that I had changed to 3, 4, and 5, and 3, and 3, and 4. What is your y-intercept? The y-intercept is 1. Why is the y-intercept 1?
Because we didn't put in a 1 for it, so it equals 1.
So notice we had y equals 2 to the x. I had you do 3 to the x. And I had you do 4 to the x for some of you. And I had some of you do y equals 5 to the x. Why is your y-intercept always 1?
That's your A. No.
Usually is 1.
What's another way to write the y-intercept here? What's another way to write the y-intercept? I mean, I've said y-intercept is 1, but there's also another way I could write. It's right here.
Oh, 0.
0, 1. So now, if the y-intercept is considered the point 0, 1, how come all 4 of those will give you a y-intercept of 1? What always equals 1?
The y.
How? You're on the right track. How?
Because it can't be 0.
This is like one of those
I don't know. I didn't know if it was
proofs
one of those.
This is like one of those things, you know.
The
the-
y-intercept is located at the point
Exponent
0,
is always
1, and x is what?
Exponent is always
What is the x-coordinate in this point?
0.
0. So if the x-coordinate is 0,
Anything to the 0 power is 1.
anything to the 0 power is always 1. So that's why your y-intercept will always be 1. It's because I could have y equals 10 to the x, and 10 to the 0 power is still going to be 1. Okay? X-intercept, there is none. Why is there none?
It never touches.
It never touches the x-axis. There's an invisible boundary. Asymptote, we have the asymptote at the x-axis. And then it talks about the fact it's always continuous because there's no breaks in the graph. And then it talks about end behavior. And we talked a little bit about that. I'm not concerned with that so much. Okay, let's look at this next one. Okay, the exponential decay. Now notice here what it says. B is between 0 and 1. So in other words, what must B be if it's between 0 and 1? It must be like a fraction or a decimal. So I could use y equals, since a lot of you said 0.5, let's try 0.5 to the x. Okay, see what you get. If some of you else want to do something, you could do 0.25 to the x. We could also do, in our example that we had before, 1/3 to the x. You're going to notice that the only difference is the fact that this graph is now going to go down. So when we think about exponential decay, anybody think about what would be an example of exponential decay? Profit margin, like you're going down. Another thing would be like half-life of radioactive elements. You know, the radioactive elements, they go down. What would be something with exponential growth?
Rabbits.
Yeah, multiplying. Actually, that is one of the things.
That's what I was taught.
So now, with that in mind, we're going to talk a little bit about compound interest, and that's where we're going to end today. Compound interest. This is a formula you should already have. P is your principal, R is your rate as a decimal, N is the number of times compounded per year, and T is the time in years. Okay? So, P is your principal. That is your starting amount. Starting amount. That is what you start with. R is your rate, always specified as a decimal. Okay? So if we would have like 9%, we would use 0.09. Okay. Along with that same line, if you would have 7.5%, you would have 0.075. Don't see a lot of rates like that anymore. A lot of the rates are actually 1% and below. I know that like some of our, like our money market account, I believe is at 0.25%. So when it's 0.25%, that would actually be 0.0025. Yeah, not a whole lot. I remember savings accounts used to get about 3% when I was growing up. N is the number of times compounded per year. So we're talking about quarterly. Quarterly means how many? 4. Semi-annually. Semi means 2, okay? And then T is your time in years. With that in mind, you've all written that formula down. I want you to go ahead and solve this problem for me, okay?
All right.
Want you to go ahead and round to the nearest cent. So just make it look like money, okay? Oh, there we go.
Yes.
Okay, so I already see that we were pretty much right on track right here. 10,157. Actually, the answer should be 88 because I had told you to answer it in terms of money. Biggest mistake that gets made here, if you use this on your calculator, you need to make sure that that number you put in the exponent, it needs to be placed in parentheses. Okay, so make sure you put parentheses around this.
I never did. We'll put
Okay,
judges.
if you already have it in the pretty print mode and it shows as an exponent, you're fine. But if you don't have it in pretty print mode, you need to make sure you put the 4 times 6 in parentheses, because otherwise what it's going to do is it will do the power to the 4th, and then it will take whatever answer you get times 6, and so you're going to get an extremely large answer. Okay. So now that is basically compound interest. That is when it's compounded quarterly. Now what happens if it's compounded continuously? Oops. If it's compounded continuously, we use the exponential function e. E is located on your calculator. Okay, it's located on your calculator. There are 2 locations. So I'll let you get that down and then we'll talk about where it's located on your calculator. there are two locations. The first location is with the LN button by the 4. Okay, next to the 4, you're going to notice in blue, it says e to the x power. That is the one you want to use. The other one over here with the division sign is actually e to the first power. Okay. So basically I'm taking my principal or my starting amount times e to the RT power. Rate has to be as a decimal again. Okay, so principal times e to the RT power. So what we would do is we would do like $750 e to the 0.03 times 4 power. Now remember, again, if you are doing the non-printy print mode, what you would have to do is put parentheses around that. And it'll actually do that for you. On your calculator, when you hit that E button, it'll do this, E caret, and it'll give you the left parentheses. So then all you would do is 0.03 times 4. Okay, with that in mind, I want you to complete this next problem. Okay, this one shouldn't take you very long. How much do you have after 5 years if you invest $5,000 at 1.2% compounded continuously? How much do you have after 5 years if you invest $5,000 at 1.2% compounded continuously?
I know you're doing. Be better.
So go ahead and enter your answer in. So now you can see, this one I didn't have the variation pulled in, so this answer here, 5,309.182733, that would still be acceptable. Okay, so let's go ahead and look at what we needed to do here. Here's 5,000, that's our principal. E to the rate is 0.012 because it's 1.2% as a decimal. Okay, yeah, the 1.2 is a decimal to start with, but you need to transform that to the percent as a decimal. And so there you go. And when you do that, you got your answer. Questions?
No.
That's pretty much it for today. Your assignment's on page 166, 2 through 32, the evens.